Hi, I am Harshpreet Kaur. In this video, I will demonstrate task 3.1p. I will show the hardware setup, demonstrate the working system, including live readings on Arduino IDE and Node-RED, explain the software code. This task focus on using Arduino to read sensor data, send it to Node-RED and automatically respond to changes. Before moving to software, let me explain the hardware setup. All the sensors are connected to Arduino pins as required. Let me show you. This is my Arduino Nano 33 IoT and this is my light sensor which is BH1750. Its VCC pin is connected to 3.3 volt on the Arduino. Its ground pin is connected to the ground. SCL pin is connected to the A5 and STA pin is connected to the A4. I connect the Arduino via USB cable with the computer so that it can send readings on the Node-RED. This simple wiring allows Arduino to read sensor values and forward them to Node-RED continuously. Now I am going to explain my software code. This code is divided into few logical sections. First one is libraries. We include libraries to control sensors and handle serial communication. Setup function. Arduino initializes sensors and starts serial monitor. It prints a message if the sensors are ready. Loop function. Arduino continuously reads sensor values, for example, light intensity or distance readings. This structure ensures the system runs continuously, readings are accurate, and Node-RED always has live readings. Let me show you the live demonstration of this setup. First, we are going to select our board, Arduino Nano 33 IoT, and our port, which is required. And after that, we are going to compile our code and upload it. When the compiling is done, we are going to upload it. When the uploading is done, we are going to open the serial monitor at the baud rate of 9600. Here is my sensor. The values are around 80, 66, 65, 68, which means it indicates the room brightness. And if I cover the sensor with a cloth, the values drops to the 0.00 lux, which means it indicates the darkness and it doesn't able to detect any light. And after that, when I flash the light on it on the sensor, the values are increasing so much high into the thousands, as you can see on the serial monitor. So it means our sensor is working correctly. On the Arduino IDE, now let it show on the Node-RED. So it's time to open the command prompt and we are going to type the command there, Node-RED, to access the Node-RED dashboard using the link given. Here it is. And it also tells that our sensor is connected at the COM10. Now we are going to open this link. You can see our Arduino light sensor is connected and our readings are come on the Node-RED dashboard. Similarly, we will also check here, is our sensor working here or not. So the values are around 53, 50, 51, which means It indicates the normal brightness of the room, as I mentioned earlier for the Arduino ID. But now we are checking on the Node-RED dashboard. So the first part is working clearly, that it detects the normal brightness of the room. And it also sending the alerts, you can see here, when the value goes below the given threshold limit. And when I cover the sensor with a cloth, the values drops to 0.00 lux, which means it doesn't able to detect any brightness, as I mentioned earlier also. And it means our second part is also working very well. Now it's time to check it with the flashlight. Is it working here or not? So I put the flashlight on the sensor and see the values, the readings are increasing. The values are 4,000, 5,000, 21,000. It also ranges from 8 to 9,000 also. So it means our sensor is working correctly here also with all the three parts. Which one? First one is our detecting the normal brightness of the room. Second one is we have to cover the sensor with a cloth. That one is also working. And the third one is we have to put the flashlight on the sensor, and that part is also working on the on the Node-RED dashboard, as well as on the Arduino ID. But I wanna tell you one more thing which you maybe not noticed or not. You can see whenever values goes below the set limit, it sends the alerts via email notification. And when I put the flashlight here, the values are also sending alert to the email, which means that, let's summarize it what I want to say. Whenever sensor detects the value low or low from the given limit, it sends the alert via email, which we have given there. And when the sensor detects the higher value from the given limit, then at that time it also sends the alert to the Gmail. Now let's check it. First, in our command prompt, you can see the values are going. The email is also coming there, on which Gmail the alerts are going. Let's check our Gmail. As you can see, the alerts are coming there. The subject is terrarium sunlight alert, and when the sensor not able to get the sunlight from the given set limit, then it set sunlight is off. And when it gets the higher value from the given threshold limit, then it send alerts that sunlight is on. You can see the value here, it is in the thousands. Concluding, let me summarize the benefits of this system. Real-time monitoring. Both Arduino ID and Node-RED show live sensor readings. Second one is automatic response. Node-RED triggers alerts or actions based on data. Continuous operation. System runs reliably without manual intervention. And the last one is visualization. Easy to understand data via Node-RED charts and gauges. So, in this video, I have shown the hardware setup and explained the software code. demonstrated the live readings on both Arduino ID and Node-RED, and confirmed that the system works correctly with automated responses. Thank you.